integrate 3x squared over x squared plus 2x plus 1 by first acquiring a proper rational function. So the degree on top is the same as the degree on bottom. That's not allowed for proper rational functions. And remember, proper rational functions are the only ones we can actually integrate, okay, using our partial fractions decomposition technique. So the first thing we want to do is split up this improper rational function. I can't seem to draw a straight line. Not a straight horizontal line. There we go, a little bit better. Okay, so we got the 3x squared on the bottom, on the top. We'll put in some placeholder values. And then we've got x squared plus 2x plus 3. That's what we're dividing by. Now, how many times does x squared, always use the leading term, go into 3x squared? Well, 3 times. So I multiply through, and we subtract, and we'll get minus 6x minus 3. And since the degree of that is less than the degree of what we're dividing by, we're done. And what does this tell us? We can rewrite this improper rational function as 3 plus this proper rational function, which I guess we could write it as minus that proper rational function just to take all the minus signs out. Okay, and now we want to integrate this, but it's the same as these, so we can just integrate them. And now we've got a proper rational function. We have acquired what we were asked for. Now let's use the method of partial fractions to simplify this even more. So we've got our proper rational function, and now we've got to integrate. So how are we going to do that? So 6x plus 3, x squared plus 2x plus 1. Now think about the denominator. Can we find roots? Can we factor that? Turns out it's x plus 1 squared. And when we have repeated linear factors, right, we have to alter our setup here. Okay. We need to solve for our constants a and b. So we multiply both sides by x plus 1 squared. All right. And well, we could plug in things like x is minus 1 and solve for a. Here's another way, because I don't think we see this enough. We can expand it out, say ax plus a plus b. Now, a plus b becomes a constant term. Ax becomes our linear term. But the nice thing about polynomials is they can only be equal if their coefficients are equal. So 6 and a, they're both the coefficients of x. That tells me right away a has to be 6. Okay. The constant terms have to be equal, so 3 has to be a plus b. But we just said a is 6, so b is negative 3. So a is 6, b is negative 3, and we're all set. So we want to integrate 3x squared over x squared plus 2x plus 1. We can rewrite that as 3 minus, and now we're going to have to be careful here, because we're splitting up the 6x plus 3 over x squared plus 2x plus 1. So we've got to be careful. So 6 over x plus 1 plus 3 x plus 1 squared. So 3dx minus 6 over x plus 1 minus, because the minus sign should distribute, 3 over x plus 1 squared. And now we're all set. So 3x minus, take out the 6, and we'll get ln x plus 1, minus, take out the 3, and you can integrate. You can use a substitution, or you can use our building block formulas, and we'll get x plus 1 to the minus 1. Well, minus x plus 1 to the minus 1. So it'll be plus 3 over x plus 1, I think is probably the nicest way to write that. And we don't forget our plus a constant. and we're all done.